So this is like the first, like today's our note day. This is like the first note day that we've had in weeks. It's been a while. I wasn't even sure what I was going to teach you until this morning. I had a bunch of slideshows that I was going to do, and I decided on this one.
That's cool.
Because this one is, and I couldn't find this one. This was the one I wanted to do, and I looked, and I looked, and I looked through all of my drives this morning, and I could not find it. Finally, I looked up my archived Google Classroom last year, and there it was. And sure enough, I did not save this one in my drive, but I found it. This one is my second or third most favorite slideshow I give all year. So yes, this is a pink dolphin. Who knew that dolphins lived in freshwater rivers?
What?
Yeah, there are dolphins that live in large freshwater rivers.
And they're pink.
Some species are pink,
No,
not
just
all.
flamingo.
Not all species are pink. So there are 3 major species of river dolphin that live in the world. I think the next slide actually show a picture of where they're located. But I know this is the Amazonian river dolphin. Not all Amazonian river dolphins are pink, but these ones are. And it's just like flamingos. Does anyone know why flamingos are pink?
They eat
Because
crab.
they eat things.
They eat algae that is pink, and it turns their feathers pink. This is the same situation with the Amazonian river dolphin. These guys are primarily algae eaters, and because of their diet, it stains their skin pink. Some river dolphins are very pink, like this one. Some have gray and pink spots. The other places you can find river dolphins, I think the Ganges River in India and Asia has river dolphins. And then there is a river in Saigon, Vietnam, that has, maybe that's the Ganges, and then it might be the Indus. It might be the Ganges, the Indus, and the Amazon rivers that have their own individual species of river dolphin.
Man, we could have river dolphins in the apple room. That's tiny.
Maybe if there weren't dams.
That would attract us.
And tubers.
So, like,
Could you imagine us fishing out of the apple and then all of a sudden there's just a dolphin just like.
Well, here's the thing. So about 15 years ago, during the winter, there was an ice fisherman's truck that went through the Mississippi River and went down. While they were salvaging it, so you had to pay a diving crew, a recovery team. They go down, they hook up the cables to your truck or your vehicle that goes through. They pull it back up. When they went down into the cab, there were 2 full-size bull sharks sitting in the cab of the truck.
God, in the Mississippi.
In the Mississippi River. Bull sharks have the ability to breathe fresh water. In fact, they breed in fresh water. They can travel a great distance up freshwater rivers. And the question is how do they get there? To be able to get from the Gulf of Mexico all the way up to Lake Pepin, where this occurred, Pepin, Wisconsin, they would have had to have traveled through numerous locks and dams. So that was one way they got there. They actually swam all the way up to these locks and dams to get there. The second is that somebody actually put them there. And the third was that they've been there. There's been a small population of bull sharks living there since they put the dams into the Mississippi River. So there's like 3 different scenarios. The most plausible one seems to me that it would have been caused by a pet owner bought these bull sharks on the black market and then released them. It's not impossible for them to swim up. It's not impossible for a small population of bull sharks to have lived the 80, 90 years that the dams have been on the rivers. It just seems unlikely.
What they do with them?
They were very weak and sickly, they would not have survived in the river much longer because it was so cold, which is why they assumed that a pet owner put them in there. I think they actually took them, and they are now, or they were up in, for as far as I know, a couple of years ago. They are in the aquarium at the Mall of America.
Oh, wow.
I don't know if they're still alive or not, but that's where I know they took them. So they're at Sea Life Aquarium. Here we have a picture of the Amazon and all the rivers that flow into the Amazon. From these rivers, there are different subspecies of Amazonian river dolphin based on what river they live in, what resources are there, what kind of separates the rivers from each other. Could be any number of things that could separate it. There could be a physical dam there. There could be a shallow part that the dolphin can't actually swim over. Could be that the river that particular dolphin in is warmer, the Amazon is colder, so the dolphins don't tend to cross over into different water from different rivers. But from the Amazon alone, there are 4 different subspecies of Amazon dolphin. They all fall under the genus and species of the Amazonian river dolphin. But if we look at the DNA, we look at the populations of each, where they located, what they eat, how they breed, how they react with other ecosystems, there are 4 independent species of river dolphin, just based on the niche that they fill. Not to be confused with niche, but niche. So this is the big topic for today: species interactions, community structure, and ecology observations. So we've talked a little bit about this part all year with energy flow. When we go up a trophic level, so we start at primary producers get 10% of the sun's energy. They store it inside of them. Of that 10%, we explode it to 100% of the plant's energy, and every time you move up the chain, you are getting 10% of the original energy stored within the plant, or within the tree, or the leaf, or whatever part of the plant you consume. So if you had 100% energy, if you are a vegetarian, you are always getting 10% of the energy that plant has, or about 10%. Depends on how efficient your digestive tract is. It depends on what you're eating. But in general, if you're a vegetarian, you are always getting 10% of the energy from the plant you consume. If you are a secondary consumer, meaning that you eat vegetarians, you eat herbivores, you are getting 10% of their energy. So if we look at cattle, for example, cattle get 100% of the energy from the corn, or they get 10% of the energy from corn, they get 10% of energy from the wheat, the grains, all of that they eat, they get 10%. If we eat a cow, we are getting 10% of the energy stored in that cow. So if we were to extend this back to the primary producer that the cow ate, the grains the cow ate, the corn the cow ate, we are getting 1% of that energy.
Corn.
If we take cows, let's say we take a bear, and then we eat a bear. It happens. Some people eat bear meat. It's not unheard of. It's pretty gamey, but you can do it. If you were to eat a bear, you would become a tertiary consumer. You would get 0.1% of the energy that originally came from that primary producer that started this whole food chain. Okay? Right now, or for most of human history, humans have been pretty vegetarian. We would eat meat on rare occasions because meat is hard to get. Meat moves. Meat runs away when you chase it. Meat doesn't like spears. So for most of human history, we have been vegetarians with a slight tendency to be omnivores, because we would eat meat if it presented itself. It wasn't until like the last 200 years that our diet has completely shifted. Now, for the most part, most of human society are meat eaters. We eat very little vegetarian or veggies. We don't eat a lot of salads. We don't eat a lot of plants. We eat mainly meat. Most of the time, humans land right here. So right now, there's 7.5 billion people on the planet. Most of us are eating at the secondary consumer level. If we jumped it down, so that in general, I'm not saying you can't eat meat. I love meat. Nothing makes me happier than a nice prime rib. But if we were to, as a society, adjust our tendencies just a little bit and go from a secondary consumer where we're getting 1% of the energy that plant originally consumed by that primary consumer had. We're getting 1% of it. If we were to jump down and become mainly primary consumers, meaning we have a greater tendency to be vegetarians or just have more of a vegetarian diet. I'm not saying like you have to completely switch. I like my meat. I'm not saying it's right or wrong one way or the other. I'm just pointing out that the data says if we were to do that, we would get a larger percentage of the energy from that plant. You physically have to eat less because you have more energy that you can use up in that plant. Versus when you eat a cow, you are only getting 1% of the energy that plant had. When you eat a cow, you're getting 1% of that energy.
Because
the cow uses up the energy. Most of the energy the cow uses up. Plus, when you digest that meat, you're not eating the whole cow.
Why not?
You're eating one tiny chunk of its butt.
Best part.
I'm a primary consumer.
What's this unit called?
Don't know some people.
I think it's large-scale ecology.
Some people eat like the liver or the heart of a deer sometimes.
Arguably for me, the heart is the best part of the deer. It's the only organ that pumps and tenderizes itself its entire life, and it pumps continuously. Yes, it looks weird. It's not like you throw a heart on a frying pan and cook the whole heart. You cut the heart up into slices and you cube it. So it's little cubes of heart. You can't knock it until you try it.
I got to play with a deer heart last year and give him that. It was really fun.
So when we look at these food webs, we can see this happening. If we think of the rule of 10%, if we think of energy, we have our producer. And in every ecosystem, you have some sort of producer. You can't have an ecosystem without it. We've kind of talked about it a little bit, but we haven't focused on it. If we look at these two ecosystems, we have eelgrass, we have a tree.
It looks like a green plant.
There is always going to be, when you look at a population, there's going to be more. Dang it, I'm not on my smartboard computer. There is going to be more producers in your ecosystem than any other grouping. There's going to be more producers than there are primary consumers, secondary consumers, tertiary consumers. There will never be less. If there is, there's going to be a problem. If we jump up an energy level to our primary consumers, these guys, there is always going to be more of the primary consumers than there is the secondary consumers. There is always going to be more secondary consumers than there are tertiary consumers. Because if there were more orcas than otters, that's not a sustainable food chain. The orcas will not have enough food because there's more orcas than otters. Those orcas would eat all of the otters, or almost all of them. The population would crash. And this is all because of our law of 10%, our flow of energy. When you run out of energy, you die. When your tank empties, you die. So when we look at populations, there's a couple important players. Every species in any ecosystem, plays an important role. But there are a few key players that are way more important than any of those other species. It's just based on the role that they play. So we have a dominant species. A dominant species, a species that has a substantial impact on the community. Without them, the ecosystem will collapse. The ecosystem would look completely different. Because this species there's so much of it in that ecosystem. Without it, nothing else can survive. The whole food chain gets thrown off. If you have high biomass, that makes you a dominant species. The species that has the most numbers of individuals in an ecosystem is a dominant species. If you have low biomass, like a wolf, you are not a dominant species. There's not a lot of wolves to deer. There's not a lot of wolves to trees. But if we think of something like coral, if you go to a coral reef, if you scuba dive or snorkel, and I strongly encourage everyone to do this at some point in their life, there is vastly more coral than fish. There is vastly more coral than crabs, than snakes. Because coral is the dominant species, every other organism that lives on a coral reef relies completely on the coral that makes up that ecosystem. Without the coral, there's no coral reef. There's nothing. There's no home for them to live. The fish don't exist there. The crustaceans don't have a place to live. The snakes move on. Trees, it's the same thing. You take a patch of woodland, a forest, you chop the whole thing down and turn it into a farm field. Do you have birds living there anymore? Do you have deer really living in that cornfield anymore?
No.
Do you have squirrels? There's the occasional organism, but they don't call it home.
Yeah.
They're passers-by. Once you remove that forest, you chop down all those dominant trees. Everything moves on or they die. A squirrel will not make it in an open field. Birds have too good eyes. The second species is the keystone species. So we have a dominant species, the species that has the most biomass. Our second key player in any ecosystem is our keystone species. This is a species in a community on which other species depend. Maybe not directly, maybe not in a way that you would think, but they completely rely on this species. Without this species, the ecosystem doesn't necessarily collapse, but it changes significantly. So I've got 3 pictures here. I have sea otters, I have beavers, and I have wolves. All 3 of those are keystone species in the environments that they're found in. And without them, their environments, their ecosystems where they should be, look completely different. If we look at the sea otter, does anyone know what the sea otter consumes? Sea urchins. Oysters. Sea urchins, oysters. They eat off the bottom. They flip on their back, they go to the surface, and they smack, they take tools, they take rocks and smack the oysters and the urchins open. It's the cutest thing ever. Without the otters, Otters consume large numbers of sea urchins. Sea otters are found on the Pacific coast along California, Oregon, Washington, Vancouver, Canada. If you know anything about the sea coast over there, there are large amounts of kelp forests that these sea otters live in, along with great white sharks, along with killer whales, along with tuna, along with salmon. All of these organisms live in this kelp forest. Otters eat sea urchins. What do you think the sea urchins eat? Kelp. This kelp is not small. These kelp forests some can grow like 100 feet tall or 100 feet long. These kelp can grow, if not longer. They're huge. They have little balloons that they fill with gas, and those gas balloons hold the kelp up. And a army of sea urchins can level a kelp forest. So when we remove these sea otters, nothing's eating the urchins. The urchins have free roam over the kelp forest that all of these organisms call home. So because we remove sea otters, we destroy an ecosystem. That makes the sea otter a keystone species, because all of these other species rely on the sea otter, whether they know it or not. Right now, we have a shortage of sea otters. Our sea otter population in the Pacific Northwest is hurting. Does anyone have a guess why?
Fishing.
Fishing has everything to do with it. So the human not so much anymore. Their sea otters are kind of protected for that. Fishing has everything to do with it. We eat a lot of fish. I think like 3/4 of the world population, the human population, relies on fish as their primary source of protein. So we do large amounts of fishing. What types of mammals eat fish? What? Huh? Other mammals though, not sea otters.
Sea mammal.
What's something that looks like an otter that's also a mammal? Walrus, which are found not this far south. Not beavers. Not seals. Sea lions.
Those look like
What eats seals and sea lions? Orcas. Because the fish population is really low, our seal population is really low. So the orcas don't have enough food. There's not enough seals for them to eat. So what are they eating? Sea otters. Sea otters. Keystone species. Beavers, same thing.
Why'd you kill one?
Yeah, honestly, that is not.
Beavers. Beavers are one of the second most destructive organism on the planet.
What's the first?
We are.
Oh.
Beavers are the second. Beavers will move into an area that's a forest with a small creek running through it. They turn it into a marsh.
That's cool.
They turn it into a marsh. They completely change their ecosystem to fit their needs. When you turn a river into a pond or a lake, how does that affect the new species that are going to move in there? It gives them a what? A home, place to live. You make a river into a pond, now ducks can live there, geese, you got new species of fish that can move in, you got new types of plants that can call this place home. Without those beavers, that place does not exist. The beavers completely change ecosystems. Not as much as humans do, but they're number 2 on the planet. And wolves. Anyone heard the story about how adding a wolf population changed the direction a river flows?
Oh, Isle Royale.
Well, Isle Royale, wolves play an excellent, like, keystone species in Isle Royale.
I think I've read that article, but I don't remember.
How does it do that?
So,
It's a chain reaction.
we can all agree humans don't like wolves, right?
Scary.
Can you name a movie where a wolf is not portrayed as a villain?
Dances with Wolves.
Fantastic Mr. Fox.
Julie
There's this
Alvarez.
one movie where the guy
Alto.
where he tames a
Well,
wolf.
Well, yeah,
It's like-
but in general, think of the stories you read as children.
Beauty and the
Big
Beast.
Bad
Beauty and the Beast. Wolves are villains.
Three Little Pigs.
Three Little Pigs. Wolves are villains.
Little Red Riding Hood.
At Twilight, villains.
Bit-
Little Red Riding Hood, villain.
Because humans are bad.
There's plenty of them. Anyone ever read Peter and the Wolf?
No.
I've heard of it.
No, there's Wolf is the bad guy. Wolves, for 100 years, did not live in Yellowstone National Park. 100 years. No wolf population. The elk population skyrocketed. Because the elk population skyrocketed, what happens to vegetation?
It dies.
It dies. The elk physically graze all the small bushes, all the saplings that would turn into full-grown trees. They graze it flat. So you have open fields. How does that affect the animals that were in Yellowstone National Park that rely on forested areas to live?
There's no
They
food.
don't have anywhere.
There's no food. There's no habitat for them to live. They physically have to move on or die. So about 30 years ago, 20 or 30 years ago, they reintroduced the wolf population to Yellowstone National Park. Once you reintroduce wolves, the elk, the deer get skittish. They now stop grazing in open fields. They move into forested areas. Because there's not elk and deer in these open fields, your shrubs, your saplings, your small trees start to grow. And when they start to grow near rivers and streams, now there's populations of beavers that can use that wood to make a home for themselves. Dam a river, make a new lake. And when these beavers moved in, they changed the flow of the river itself. Without the wolves, the shape of the rivers look completely different than the Yellowstone with rivers. Keystone species.
Keystone species. Can we make a cheer? Keystone.
What's my dominant species in this prairie?
Yellow flower.
Flowers and grasses. Dominant species here. Shrubs. Dominant species here.
Coral.
Coral. What could be a keystone species?
Fish.
Coral.
Fish. Sea kraits. Large fish. Sharks. Sea kraits are sea snakes. They've got flat tails. That's cool.
Secrets.
Kraits.
Secrets.
Let's keep moving. This class gets done at 40.
Something. 47.
47?
Yeah.
We got time. So whenever we look at a population, an ecosystem, ecologists kind of think about how many individuals are in that population based on the biomass. That's physically how much mass of living organism you have in an ecosystem. How much organic matter do you have in an ecosystem? So we can look at the biomass of a successful community, a successful ecosystem. And if we have a thriving ecosystem, we have a large amount of biomass. If our ecosystem is dying or isn't doing as well, we're going to have a low amount of biomass. So rainforests, high levels of biomass. Coral reefs, high levels of biomass. Deserts, not so much. The middle of the ocean, the deep ocean, the abyssal plain, all those places have low biomass. There are organisms that live there, but it is much less than the diverse ecosystems like coral reefs and rainforests.
Well.
Yeah.
Can I take a trip to the bathroom?
Yep.
Thank you.
What happened to Kendra?
I don't know where she's at. She's been in the bathroom for a while.
Here we have a chart talking about prey biomass to predator biomass, specifically lions to impala. If we look at the predator biomass, what's our scale go up to? 100. If I look at my predator or my prey biomass, what does our scale go up to?
Big number.
10,000. There are always significantly more prey in any ecosystem than there are predators. If that flips, we got issues. There should never be more predators than prey. If there are, predators are going to die off. Prey are going to die off. The population of both individuals are going to hurt. Does anyone know what bird this is?
Carrier pigeon.
What kind of pigeon?
Carrier.
Not a carrier pigeon.
Bro, common pigeon.
Nope. It was common at one point.
On the bridge the other day.
Oh,
It's an extinct pigeon.
Was this the one where people use it as like sports?
Yeah, this is the passenger pigeon. It was once the most common bird on the entire planet. It flew in flocks of not 10 birds,
100.
not 100 birds,
1,000.
not thousands of birds,
100,000.
not hundreds of thousands of birds.
Millions.
It flew in flocks of millions of birds.
Wait, you aren't joking?
I'm not joking.
What?
One flock contained millions of individual species of individuals of passenger pigeons. Millions.
That's insane.
My high school math teacher, his great grandfather told him stories of the passenger pigeon. When a flock flew over top of you, it would block out the sun. There were that many animals in that flock. It would physically block out the sun. There are reports that flocks were so big, it would take 3 days for the flock to fly over you.
Nuh-uh. That's so cool. I don't want to leave.
How many do we have now?
0.
0. None. Zip. They do not exist.
Bye, everybody. Oh my.
Here's an illustration of what one of these flocks look
Looks
like.
like a tornado. Tornado.
They were very beautiful birds. They had red stomachs. They're much more pretty than carrier pigeons or any pigeons we have now. They had red stomachs, white tails with green heads. Their flocks were massive. They would nest on the ground in Canada. They'd lay like 1, maybe 2 eggs. And they would migrate to Mexico, South America. They'd migrate, or not South America, Mexico and southern United States, I believe. But they were huge.
So what happened?
This is a quote about, I think this was from Walt Whitman, about the passenger. So the passenger pigeon may have been the most abundant bird since Archaeopteryx. It fluttered its first feather back in the late Jurassic. That's the Archaeopteryx. John James Audubon rode the 55 miles from Henderson, Kentucky to Louisville one day in autumn in 1813. And through the whole long day, he rode under a sky darkened from the horizon to horizon by a cloud of passenger pigeons. He estimated that more than 1 billion birds had passed over him. In 1866, a cloud of birds passed into southern Ontario. It was a mile wide and 300 miles long, and took 14 hours to pass a single point. Later day estimates suggest something in excess of 3.5 billion birds in a flock. The continental population may have been as high as 6 billion birds at one point. So across North America, at one point, estimated there were 6 billion birds. A number that could represent anywhere from 25 to 40% of all the birds in North America 350 years ago. So if we go back to the year 1600, the passenger pigeon population, if we looked at every single species of bird, accounted up to 25 to 40% of all bird species on North America 400 years ago. And now we have none. This is their primary range. They mainly bred Wisconsin, Michigan, Indiana, Ohio, Pennsylvania, New York. They would migrate throughout most of middle to eastern United States, Canada, Mexico. That's where they lived. This is what they shot them with. It's a 2-gauge shotgun. A lot of time people don't even hold this. They mount it to the front of a boat. It's a cannon, basically. They shoot this once, and hundreds of birds fall to their death. One shot. And they go out for hours. And they would shoot thousands of birds every day. They didn't eat them. They just killed them for sport because they could. Because they could.
Hi, I'm Chris. Lucia, nice to meet you.
And welcome to the Vision of Birds.
Thanks.
The Smithsonian has one of the largest collections in the world, open to scientists from all over.
Anyone who wants to come and study birds, they can either come here and work with us, or we can loan the specimens to them.
One specimen stands out above the rest.
Oh my God, you're kidding me. That's Martha?
This is Martha.
For a pigeon fan like Lucia, this is like seeing a movie star, the very last passenger pigeon.
She died at the Cincinnati Zoo
Yeah.
at 1 p.m. on the 1st of September, 1914. She was literally alone for about 4 years before she died, and we knew at that time that there were no other ones in the wild. So this is one of the rare cases when you can actually place an exact time and date on an extinction.
Today, Martha sits for posterity beside her companion, appropriately named George, a fellow passenger pigeon who died long before her. Hundreds of years ago, passenger pigeons were estimated to be about a quarter of the total bird population of the United States. A flock a mile
25%.
wide, flying 60 miles an hour, could take days to pass overhead. So, where did they go?
The story really is not a simple one. There are a lot of factors involved with any extinction. In this case, there was a lot of market hunting. They were easy targets because they occurred in these large flocks of over 1 billion birds. A hunter could go and collect thousands at a time without, really having to try that hard.
Passenger pigeons became a staple of the American diet. By the end of the 1800s, millions were being shipped back to cities in the East. Another natural factor sealed their fate.
They didn't lay as many eggs as other pigeons, so it was easier to wipe them out
Yeah,
that way, right?
yeah. The biology of the passenger pigeon was such that they really relied on those large flocks for a couple of reasons. One was protection from predators. There's safety in numbers, and they didn't have to lay a whole bunch of eggs to reproduce. So in a matter of just a few decades, we're just all gone.
Once a species is gone, no amount of wishful thinking can bring it back. Birds still go extinct, but the the loss of the passenger pigeon made people take notice. It prompted the very first legal protections for migratory birds.
So, once accounted for 25% of North America's overall bird population, eradicated in like 50 years. There were billions of birds, upwards of 6 billion to 0 in like 50 years. It was out of this terrible situation that we end up pushing into the mid 19th centuries and into the 20th century into this idea that, you know what, humans can have an effect on the ecosystem. Up until this point, the belief was no way. Nothing we do will change the ecosystem. Nothing we do will change the way the earth looks, the way the earth acts, behaviors. We have zero effect over it. And there's still a little bit of that mentality today. But this was an awakening. The fact that you could completely eradicate the most populous bird, arguably ever, in 50 years. This is what led to the creation of the DNR. The idea of conservation came out of this. And we call this situation the tragedy of the commons. This is kind of one of the first times where we start to realize human effect and how humans themselves, how we have kind of become a keystone species for almost every ecosystem, especially when you start removing the other keystone species, like Wisconsin itself. Wisconsin was always free range for wolves. Wolves were our keystone species. When we remove those wolves, there's no keystone species, there's no control. Populations can run pretty wild. And that's one of the reasons our deer population is so large. Because there's no predators, at least not a large population of them, that can sustain our deer population, which is leading to the CWD, the chronic wasting disease, and other deer-related and other animal diseases. We have become the keystone species. So without humans involved in these practices of hunting, most of our populations, most of our ecosystems would suffer more than they already do. Which is one of the reasons why hunting is so important. Until we have that wolf population back, humans have to. Whether you like it or not, we have to keep those populations under control. We've got a little time here, so I'm going to show this video kind of explaining the tragedy of the commons and what it is.
Imagine as a thought experiment that you live in a small village and depend on the local fish pond for food. You share the pond with 3 other villagers. The pond starts off with a dozen fish, and the fish reproduce. For every 2 fish, there will be 1 baby added each night. So in order to maximize your supply of food, how many fish should you catch each day? Take a moment to think about it. Assume baby fish grow to full size immediately, and that the pond begins at full capacity, and ignore factors like the sex of the fish you catch. The answer? 1. And it's not just you. The best way to maximize every villager's food supply is for each fisherman to take just 1 fish each day. Here's how the math works. If each villager takes 1 fish, there will be 8 fish left overnight. Each pair of fish produces 1 baby, and the next day the pond will be fully restocked with 12 fish. If anyone takes more than 1, the number of reproductive pairs drops, and the population won't be able to bounce back. Eventually, the fish in the lake will be gone, leaving all 4 villagers to starve. This fish pond is just one example of a classic problem called the tragedy of the commons. The phenomenon was first described in a pamphlet by economist William Forster Lloyd in 1833 in a discussion of the overgrazing of cattle on village common areas. More than 100 years later, ecologist Garrett Hardin revived the concept to describe what happens when many individuals all share a limited resource, like grazing land, fishing areas, living space, even clean air. Hardin argued that these situations pit short-term self-interest against the common good, and they end badly for everyone, resulting in overgrazing, overfishing, overpopulation, pollution, and other social and environmental problems. The key feature of a tragedy of the commons is that it provides an opportunity for an individual to benefit him or herself while spreading out any negative effects across the larger population. To see what that means, let's revisit our fish pond. Each individual fisherman is motivated to take as many fish as he can for himself. Meanwhile, any decline in fish reproduction is shared by the entire village. Anxious to avoid losing out to his neighbors, a fisherman will conclude that it's in his best interest to take an extra fish, or 2, or 3. Unfortunately, this is the same conclusion reached by the other fishermen, and that's the tragedy. Optimizing for the self in the short term isn't optimal for anyone in the long term. That's a simplified example, but the tragedy of the commons plays out in the more complex systems of real life too. The overuse of antibiotics has led to short-term gains in livestock production and in treating common illnesses, but it's also resulted in the evolution of antibiotic-resistant bacteria, which threaten the entire population. A coal-fired power plant produces cheap electricity for its customers and profits for its owners. These local benefits are helpful in the short term, but pollution from mining and burning coal is spread across the entire atmosphere and sticks around for thousands of years. There are other examples too. Littering, water shortages, deforestation, traffic jams, even the purchase of bottled water. But human civilization has proven it's capable of doing something remarkable. We form social contracts, we make communal agreements, we elect governments, and we pass laws. All this to save our collective selves from our own individual impulses. It isn't easy, and we certainly don't get it right nearly all of the time. But humans, at our best, have shown that we can solve these problems, and we can continue to do so if we remember Hardin's lesson. When the tragedy of the commons applies, what's good for all of us is good for each of us. Ted Ed.
So the demise of the passenger pigeon came out of this idea. And they kind of, here the tragedy of the commons is a paper written by this scientist in the 1830s. But we ended up pasting it, conservation ended up pasting it to the demise of the passenger pigeon around the 1914, the early 1900s, where it wasn't just the passenger pigeon that was going through this. We saw fish populations decrease. We saw wolf populations decrease. Deer populations decreased. Because for the individual, yes, taking 5 deer at a time, that was good for me. That helped me survive. But long term, if every single person takes 5 deer, or takes more than 5 deer, the overall population of deer will crash, and then everybody hurts. So it's basically take what you need. Don't take anything more than that. Take what you need. Here we see, like I was just talking about, total populations of deer throughout the last 500-600 years. And this is an estimate. It's not exact, but this is the whole total population of deer and different species of deer over the last 500 years. In 1600, 1400, we had 30 million white-tailed deer estimated in North America. We had 15 million mule deer, black-tailed deer, elk, moose, roughly in North America up until about 1810, 1830. And then right around the extinction of the passenger pigeon, we hit an all-time low where we're white-tailed deer, mule deer, black deer, elk. We are sitting probably, based on this, about 1 million individuals per species, maybe less than that. Right here is when that tragedy of the commons occurred, where people started being aware. We need to conserve our ecosystems. We need to conserve our species so that they're there for future generations. If we eliminate them now, we're going to hurt long term because we're not going to have those resources available. So in a way, the extinction of the passenger pigeon was horrible. It was horrible. But it kind of woke people up. Sometimes it takes those types of situations to make people aware. Anyone know what this is?
Turkey.
They call these thunder chickens. These are prairie chickens. This is the greater prairie chicken. It was once extremely common to Wisconsin, Illinois, Minnesota, Iowa. Beautiful bird. And they have an amazing dance to attract a mate. But these sacs underneath its neck create this booming sound that the small chicken that's about like this big produces. It's pretty rare now. There's a population of greater prairie chickens in, there's one in Prairie du Chien, wild population. There's one population in Stevens Point. Stevens Point has the largest population, and there's a couple of Illinois. But a bird that was once common throughout Wisconsin is now limited to small populations of other birds. Anyone know why?
Because people kill them all.
Hunting is one of them.
Losing their habitat.
Losing their habitat. Anyone have a guess what they lost their habitat to?
Humans.
Humans? Huh?
Beavers.
Not beavers.
Farming.
You know what this animal is.
Oh, pheasant.
Who thinks that pheasants are native to North America? Up until I mentioned it just now. They're from Asia. Pheasants are not native to North America. They are an Asian bird. Same way as any invasive species. We bring them here. Because it's a beautiful bird. Pheasants are beautiful. And they're a great hunting bird. But they fill the same niche, the same role as this one. Did anyone know that the Wisconsin once had a species of parakeet and parrot, or a species of parrot? We did. Carolina parrot, there it is. Went extinct right around the time of the passenger pigeon.